Hi everybody, today we are going to learn about math and comparator operations inside EcoStruxure Machine Expert. First I'll open the software. So when it comes to the analog, we have to deal with both math and comparator blocks. You have to do some kind of comparisons inside that one. So it is usually used for the analog operations, or other than that, if you have some kind of comparisons or math operations that has to be done, you can go for math and comparator operations. So initially when you start the project, you can click on this inactive. Okay, then after that you can move on to the configuration. So this inactive, what we are doing is we are password and the confirmation, we are disabling it. Otherwise what happens, every time you have to set the password. You have to give the password, then only you can open the project. So once while you study, it's not necessary. So we'll move on to the configuration part. In the configuration part, I'm going to select TM221CE24R. So just because you are doing with simulation, we don't have to give the IP address, subnet mask, etc. So this part you can skip, you can avoid it. If you are doing with hardware only, you have to fill these items. Coming to the programming part, you can see an operational block here. So when you take other PLC brands like Schneemann, Salem Bradley, etc., for each and every instruction you will have, like for example operations, you will have an instruction. So for example, if you are taking addition operation, you will have an add instruction for doing that one. If you are doing greater than or equal to operation, then you will have an instruction especially for that particular greater than or equal to. So just like that, each and everything you will have instructions. But in this, you have only one instruction, that is known as operational block, which is used for both comparator and math operation. So if this is the place to take the operational block. Once I take this operational block, I can place it on the input side and the output side. See, if I place that on the input side, it becomes a comparator operator. If I place that on the output side, it becomes an operations. You can give the operation expressions. For example, you can do the math operation inside this one. You can do the move instruction inside this one. So according to the place you keep the operational block, the instruction changes. Okay. So now first we'll start with the comparator. So I'll be placing this operational block on the input side. So automatically an operator will pop up on this instruction. So here you can see less than or greater than, all these kind of things. And the heading, it is written as comparison bar operation expression. So when it comes to the comparators, you are comparing some values, and according to that values, a Boolean output will be on. So I will connect a digital output for this one. So just because I don't have any particular value coming from any sensor or anything, I will be giving an internal memory address in order to show this instruction. Let me show you with the MW0. So you have to give a percentage MW0, that's a word address. I'm going to deal with integer. So when that is greater than or equal to 75, my output Q0.0 should be on. Okay, so here you can see if the instruction is not correct, then you can see red color on this part. Okay, just because there is no error in this particular instruction, it is displayed in black color. Okay, so let's see how it is working. I'll go to launch simulator. Here we will learn how to insert the value in the online mode also. So I have to give the value for the internal memory. I'll click on this MW0. Yeah, so online data entry option will be there. I'll click on MW0 again. So here I'll give a value like 60. Let's see what happens. When I give this 60, the condition is not satisfying. That means 60 is not greater than or equal to 75. So let's change the value and make it to 89. Now you can see the output is on. 89 is greater than or equal to 75 and your output is on. Okay, so let's see some other what to say comparator also. For example, you have an option like I'll take the comparator block. I can give like this: when percentage MW0 not equal to percentage MW1, then my output should be 1, Q0.1. So this is not equal to option. So if I want to give equal to, that is also possible. So that is important. We should know the difference between equal to and when you use the move instruction. So for example, I'll give a command like this. But the previous one is not equal to this. I'll give as equal. Single equal to percentage MW1. Okay. So now I'll give the output as Q0.2. Let's download this and see. So here I'll give the value for MW0 first. So let this be 88. So 88 is not greater than or equal to 75. Your output is on. 88 is not equal to MW1. MW1 is 0 now. So I'll give value for MW1. Click on MW1. Let me give 88. Let's see what happens. So here 88 is equal to 88 in this case. So your output is on in the rung 2 just because both are equal. So if I'm changing the value, so for example, if the value is 87, so both are not equal. In that case, your Q0 second rung will turn on. The binary, the boolean connected to the output of this not equal to will turn. So you can use these commands. There are commands like less than or equal to, greater than, less than. Then all these kind of comparators can be used appropriately as per your applications. Okay, so whenever the temperature sensor's value is greater than 60 degrees Celsius or the pressure sensor value is greater than 2 bar, you want to turn on something. So all these kind of things you can go for comparator instructions. So now let's see how the math operation is working. So for that also I said to you, you don't have any particular instruction for that one, you have to use this operational block. Your operational block will be connected on the right hand side, on the output side. So let's see, I'm going to give an expression. The first one will be addition. So I'm going to add two values and the sum will be given to the sum will be in another what to say, another address. Okay, so let that address be, by sum let it be MW4. Okay, so now the expression is in such a way that you have to give colon then equal to. Okay, that's the most important thing that you have to be careful when you do with the operational block on the right hand side. So now again I'll add MW0 plus percentage MW1. It's already there on the front, on the top, so we can take the values from there. So here you can see, you do not see any red color or anything. For example, if I forget to give this colon, so let's see what happens. See, you can see the red color, there will be error. So make sure that you are doing the instruction, you are giving the instruction in the proper format. So it's very important inside Schneider. Okay, so this is add instruction. So let's see another instruction. I want to move the value from one address to the other address. What I will do is, I want to move the value inside the MW4 to another address called MW5. So how I am going to do it? So percentage, again the same format, MW5 colon equal to percentage MW4. See the format. So here comes the difference between equal to and move. So it was, you can see the equal to instruction inside the rung 2. So first thing is that will be placed on the left hand side, on the input side, and second thing is there, according to the format, there will not be any colon inside the instruction. When it comes to the move instruction, that will be in first place, that will be in the output side. Second thing, the representation will be different. You have to add a colon in between. Okay, so let's see how these two instructions are working. Launch simulator. So I'll start from the beginning. The values will be coming from here. So I can give the values from anywhere. 23. So MW1, 45. Okay. So I have given MW0 as 23, MW1 as 45. So let's see. 23 and 45. The sum you will get as 68. So whatever values in the MW4, it is moved to MW5. So here you can see the representation of that one. Okay. So now for the multiplication, addition, subtraction, all these things will be using the same format. So if you want to see, I'll just show you one division also. Maybe I want to divide something. So percentage MW6 colon equal to percentage MW5 divided by, that means slash. Okay. So MW5, so we have to start from the beginning. Give value from the MW0. So this is just for the representation I'm doing with the previous values and all. So when it comes to the actual programming, it will be different. We are now just learning how the instruction is working. So 12 and MW1, it will be like 23. So here you can see 35. So 35 divided by 2, 17. So 17, just because it's a whole number, you are dealing with word address. Word address means integer. So it will take only the whole number. So whatever fraction is coming, it will remove that and only give you the whole numbers. So you know that it's 35. So let's see. You can see here, it's 35. So 35 divided by 2, actually you should get that as 17.5. So that 0.5 is removed and it is giving the whole number as 17. So if you want to see the point value, then you have to convert this MW6 or MW5 into float. So now it is in word expression, you have to convert that into float, then you divide it, then you will get the point values. So for in some cases, for some applications, you want fine values. So for example, the values will be greater than 2.5, or I want to add a value called 2.5 to the sensor, or some kind of tolerance I have to give. In that case, I have to convert the format. After first, initially if it is integer, I have to convert that into real, and then I have to do the calculations with the real data type. Okay, so that's what the conversion happens. So let me stop the simulator. Now let me show you the conversion part also. So here I'll insert a rung. . going up. So I'll do one thing, I'll insert around here, so it will be correct. So here what I'll do is I'll use the operational block in order to convert this word into integer. So till MW5 I have used. When it comes to the float and the word, so what is the relation between float and the word? So if you are giving m of 0, m of 0 means MW0 and MW1 is included inside m of 0. So just like that, m of 2, you have your m of 1 and m of 2. Your MW1 and MW2 and MW3. Then after that, when it comes to the MF4, you will have your MW4 and MW5. So till MW5, and again, now we have MW6 also. So before going to the MW6, till MF4 it is defined. So MF4, MW4 and MW5 it is defined. So I cannot use the float till MF4. Now I have to go for MF6. So I'll delete this instruction and go for MF6. So shift percentage m of 6 equal to, so when I type integer to real, you can see the format. Integer to real will be displayed here. So you can click on this particular instruction. On the real part, it will ask which instruction, which address I have to convert. So I want to convert percentage MW5. So I'll convert percentage MW5 into m of 6. Now, what I'm going to do is, I'll convert this m of 6 into, I'll divide the m of 6 into, I'll use m of 8, percentage mf8 colon equal. Okay, so when it comes to the m of 8, so we are doing a division here. So percentage m of 8 is equal to percentage mf6 divided by 10. For example, I want to divide it by 10. So let's see how this is going to happen. So let's go to launch simulator. Start controller. Go for programming. Let me give the value for MW0, MW1 it is 2. So now, so you can see the value here. So the addition was 68, MW5 is 68. What I have done is I have converted the 68 into m of 6, the float. So now it's in point values. So m of 6 is divided by 10, what you will get? 6.8. So you will get the point values here. So for some cases, if you need a point value or a real value, what you have to do is first you have to convert it and then you can divide it. Okay, so when it comes to the analog and all, you need a particular range. So you will be receiving the value in a range of 0 to 1000 and all. Your required range will be 0 to 100 or 0 to 10 or 10 to 20, 4 to 20. So whatever range you want, you have to create it using the mathematical instructions. In that case, even the point values are important. You will get point values. Sometimes in your sensors, the point values, if the values are greater than this 2.5, 3.5 of fine adjustment, in that case you have to go for the float instruction. So this is all about math operations and operational block conversions and all. So we'll be back with another video.